Barakatu. Yeah, once again, welcome to our online classes. So, inshallah, today we shall be having some of the sample questions on the topic discussed so far. So, now, to the question one now. The question asks that the concave meniscus of water in a glass is due to the fact that, so we are given the option A to D. Now, so while we are discussing angle of contact, I said that there is a formation of meniscus when using water and mercury. So this question now asks that, so water forms a concave meniscus while mercury forms a convex meniscus. But the question asks then, what is responsible for the formation of the concave of the water? So the option 1 goes like this and B. So from here is that what make water to form a concave meniscus is that the adhesive force is greater than the cohesive force. That is, the adhesion between the glass and water molecules is greater than the cohesion between water molecules. So that make water to form a concave meniscus. Again, mercury forms a convex meniscus because the cohesive force in that one is greater than the adhesive force. I hope it is clear. Then the next one again, the tendency of a liquid to rise or fall in a narrow tube in a capillary tube is called what? That is a capillarity. To take note of the spelling. So the option A is capillary. So the correct answer is a capillarity. Okay. Now, then the next one. Which of the following is or are true? Now, the first one we have water wets glass because adhesion of water to glass is stronger than the cohesion. That is correct. Water wets glass because cohesion of water molecule is stronger. So option letter Roman figure 1 is correct, while that of 2 is wrong. Then 3, cohesion is the force of attraction between molecules of the same substance. So 1 and 3 are correct. So 1 and 3 are correct. Cohesion is the force of attraction between molecules of the same substance, while adhesion is the force of attraction between molecules of different substances. Then the next one again, the meniscus of water in a capillary tube is what? Concave. So I have explained that one to you. Then question 5 now. We are given that, I hope you are with your pen and the other writing material. So question 5 asks that a spring of force constant 1500 Newton per meter is acted upon by a constant force of 75. You are asked to calculate the potential energy stored in the string. Now, the formula for finding the potential energy stored in a string is you can use half Fe or half Ke square. Either of this is correct. Is either half Fe or half Ke square. So now, from what we are given here, we are given that K equals to 1500, while the force is 75. So, and mind you, from we need to calculate extension. Either of the formulas you want to employ, we need to calculate the extension. Then, how do we get extension? Is from the Hooke's law. So we get the extension from Hooke's law. We say that F equals to Ke, that is, force is equals to the product of the force constant and the extension. So if you make E the subject of the formula from there, we will be saying that E equals to F over K. So that means that 75 divided by 1500. So this gives us 75 divided by 1500. So that means that E equals to 0.05 is 0.05. So now going back to the formula now, work done or the energy stored equals to half Fe. So I want to use half Fe. So that means that the force now times the extension times 75 then divided by 2. So that means that the answer is 1.875 joule. 1.875 joule. So if you approximate to 1 decimal places there, we shall be having 1.9 joule. I hope it is correct. It is clear to you. Then the next one we have here also, a catapult is used to project a stone. Which of the following energy conversion take place as the stone is released? Now, so I have explained this when we are under elasticity. So we use a catapult to project a stone, but there are some energy conversion that took place. Now, so when a stone is being shot from a catapult, initially the catapult possesses an elastic potential energy. So once the stone is being released, the stone will move out of the catapult. So that means that the stone will now possesses kinetic energy. That means that elastic potential energy of the catapult has been converted to the kinetic energy of the stone. So that is the right option here is option C. So the next one again, we are given that a string of 4 meters is extended by, that means that the natural length of the string, we say that L naught equals to 4 meters. So is extended by 0.02. That means we say that E1 equals to 0.02 meter when a load of 0.4 kg is suspended. Here is that the unit of the value we are given is kg. That means it is mass. Okay, so if you want to make it the in Newton now, that is, you want to convert mass to Newton, then you multiply by 10. That means that we can say that the force there or the load equals to 4 Newton. Now, then what is the length of the string when an applied force is that is when the force has been changed to 15 Newton. Initially it is 4. So the new force again is 15. So then answer that if 4 Newton causes an extension of 0.02 Newton, what extension does 15 Newton cost? Now, so what we do here is that from Hooke's law, we have stated that F equals to KE, and also if we have more than a force and the extension, we will be saying that F1 over E1 equals to F2 over E2. Now, please take note. Here is what is the length of the spring. That is, we need to get the second extension, then extend. And you know, if you still remember, we have stated that E2 will be L2 minus L0. E1 equals to L1 minus L0. E3, that is the third extension, will also be L3 minus L0, and so on like that. So it means that once we have gotten the value of extension 2, then that value plus the natural length of that string will give us the length at which 15 Newton is applied. So if you now go by that, F1 over E1 equals to F2 over E2. So if you substitute that into time, it will be 4 over 0.02 equals to 15 over E2. So if you cross multiply, that means the extension we will be getting is 0.075. Is 0.075. So as I have stated now, so we have E2 equals to L2 minus L1. So if L naught is being taken to the side of E2, it means that L2 now equals to L naught plus E2. That will give us 4 meter plus 0.075 meter. So if you add everything together, that means it will be giving us 4.075 meter. So when you approximate to one decimal places, we shall be having 4.08 meter. 4.08 meter. Then also the next one we have here, also a spring of force constant 500 Newton per meter compressed such that its length shortened by 5 centimeters. You are asked to calculate the energy stored. Here is that K equals to 500 Newton per meter. So extension equals to 5 centimeters. So mind you, the extension has to be converted to meter. That means that we divide by 100. So that means that the extension there will be 0.05 meter. So the formula for finding the energy is you can use half Ke square or half Fe. So depending on the terms you are given, the parameters. So here we have been given K, so we just substitute the value of K and the extension. So extension equals to 0.05. If you square it, then multiply by 500 and then divided by 2. So we shall be having 0.625 joule. The formula again is a half Ke square. Half Ke square. So if you substitute, square the extension, multiply by 500, then divided by 2. So the final answer shall be 0.625 joule. Okay. Now, so the next one we have also, if a load of mass 10 Newton stresses a cord by 1.2, then you are asked to calculate the total work done. This one is like energy used in the processes. Now, so that means that we say that force equals to 10 Newton. The force they apply is 10 Newton. So extension equals to 1.2 centimeter. So if you convert that to meter, because the SI unit of length is a meter, likewise so the SI unit of extension will be meter. So if you convert 1.2 centimeter to meter, it will be you will be dividing by 100. So that gives us 0.012 meter. So now going back to the formula of work done, which is a half Fe. Since we have given F here, there is no K, so we don't need to be stressing ourselves. Just use half Fe. And if it is sometime that half Ke square goes, so you can also use the formula as well. You will have the same answer for either of the formula. So it will now be, if you substitute the value, the final answer will be 6 exponential minus 2 joule. 6 exponential minus 6 joule. Now, to the next one, we are given a graph of Hooke's law. So this is the graph, and this is the question there. So the question asks that the diagram above represents the graph of force applied on stressing a spiral spring against the corresponding extension X. The force constant is, that is, we are asked to calculate the force constant from this graph. How do we, the force constant from this graph can be gotten by finding the slope from the graph. And if you can still remember, the formula for finding and the method for finding the slope is that you look for a way of drawing out a right angle triangle from the straight line you have. So that means that you pick some points whereby that you can easily locate the values now. So from here, so I can trace this side down like this. So in order to locate the right angle triangle, so I hope you can see. So I'm tracing that line. So if you have your you can also trace it in your notes like that. So then join it, let it goes like this. So from what I have done now, so that is a right angle triangle. So the point at which you locate the point now, you now trace it down. So that means that if you trace where you started here down, so the value that goes here, you take note of it. Then also if you go here, you take note of the values here. So this value here will serve as the force 2, then where this one will serve as extension 2 now. Then at the lower part as well, this is the last part you have. So you trace this one down, you take note of the value, and then this side as well, you take note of the value like this. So this is how I locate my own triangle. So this is my right angle triangle now. So you trace all this side to the edge of the graph. So now the here is also a bit by, and this here has been taken. So you trace it with dots to locate the points now. So where the values you have here, so this one will serve as your F2, while the lower part of it will serve as a F1, I mean this side. So here also, this will be your extension 2, while this one will be your extension 1. So the next thing now is to determine the values now. So look at the intervals there. The origin is 0 here, as you can see. So you have to we have 1 2 3 margins between the value. So that means that each value is 20. So if here is 20, here will be 30, and okay 10 10, and here will be 40 50 60 7. No, it is 20 20. This is the origin is up here. Okay, now so this is 20, and here is 40. So here is 60, and here is 80. So it wasn't labeled very well. So as you have on x-axis as well, which serve as the extension, so you can see that we have to, this is where 2 start here. So you have 2 years now. So now count how many margin does you have to the next value. So we have 1 2 3 4, and this is where there is 4 now. So that means we have 4 margins in between the values. So if you now want to know the interval now, so this one will be, if here is 2, that means that each interval is 0.04. so if here is 2, this side will be 2.04, here 2.08, here 3.2, and here 3.6, and then here 4. So that means that each margin is 0.04. So to locate the values now, so if here is 80, definitely here will be 100. That means that we say that our F2 equals to 100. F2 equals to 100. Then also here again, that means that our F1 equals to 20. Then to the x-axis, so we locate a values here. That means here will be F2, which x2, which is this value, will be 6.04, and here will be 2.04. So and the formula for finding the slope, which is also the first constant, equals to f2 minus f1 over x2 minus x1. Again, f2 minus f1 divided by x2 minus x1. So if you substitute the value as we have gotten, it will be 100 minus 20 over 6.04 minus 2.04. So at the end we shall be having 20 as the value of the first constant. So the first constant also serves as the slope. Please take note, if they ask you using the from Hooke's law graph, the slope you got there is also the first constant of the elastic material. Okay, now then the next one now, it is observed that water will wet a glass. Because why does water wet glass? The main reason is that the adhesive force is greater than the cohesive force. That is why water wets glass. And if a question also asks that why does a mercury spill on a glass, so that one does not wet glass. So it means that the cohesive force greater than the adhesive force in that situation. So the correct answer here is that option B, which is adhesion of water molecule is stronger than the cohesion of water to glass. Please take note. Then the next one, from the graph, the point at which the point that represent the elastic limit. You know that from graph of Hooke's law, we have some parameters there. We have elastic limit, we have yield point, we have maximum load, and then the breaking or fracture point. So a region where you have a perfect straight line from the start of the graph to where you still obtain a straight line graph, that region is called an elastic limit. That is, a material will return to its normal sizes after the stressing force has been reduced. So followed by the yield point. Then where you have the apex of that graph is the maximum load. Then the point at which it begins to break or fracture is called the breaking or fracture point. So from here now, Q will serve as the elastic limit, while R is a yield point, X will be the maximum load, and T will be breaking point. So the correct option is option B, which is a Q, because Q serves as the elastic limit of that spring. Now, so question 141 from here now. So it is being asked that which of the following substance is most viscous at room temperature. Now, so you know that when we are defining or explaining viscosity, we have two types of liquid there. We can classify liquid as low viscous liquid, and also the other type is a high viscous liquid. Now, those ones that have more resistance to flow, they are said to possesses, or they are said to be high viscous, and those ones that possesses less resistance to flow are also known as low viscous liquid. So from here now, you can see that it is only palm oil that is different from the rest. So water is the low viscous, alcohol, and then petrol. If you see that all these aforementioned three liquid substances now, they flow at higher rate than palm oil. That means that they have a low viscous than the palm oil. Then the next question now. So from this graph, we are asked to calculate, we are asked to find the value of A, B, C, D. So I have mentioned that. So a region from the start of the graph to where you have a perfect straight line, so that is called elastic limit. Next by yield point, that is the plastic region. Then at the apex, that is the maximum load. Then D will be fracture point. So A will serve as the elastic limit here, B will be yield point, C will be maximum load, and then D will be breaking point or fracture point. I hope you got that. Then also, so question 13 here now, a steel needle floating on water sink when kerosene is added on water. This is because now from our previous discussion on surface tension, we said that we have some method of reducing surface tension. One of the method is that by boiling the liquid, by addition of camphor, by addition of alcohol and the like. So they now ask that when they add kerosene to it, what does kerosene cause? That means that it reduces the surface tension. So that means that the correct option is B. Then here also you are asked to calculate the energy store. So we have seen many examples asking to calculate energy store. So the formula is basically that you use half Fe or half Ke square depending on the parameters you are given. So when you work this out, you shall be having 64 joule as the final answer. Then the next one here also, you are asked to calculate the length. Calculate this strain. Okay, now the formula for strain is a extension over original length. Extension over original length. From here we are not directly given the extension, okay, but we have been given the original length, which is a 4 centimeter. So we convert that 4 centimeter to meter. Take note. Then how do we get extension? Is from also Hooke's law, F equals to Ke. So that means that it will be force divided by extension. So that means that 20 divided by 80. So 20 divided by 80. So you shall be having 0.25 there. Then divided by 0.04, because when you convert that 4 centimeter to meter, it will be 0.04 meter. So the final answer shall be 6.2. And take note, string does not has units. It doesn't has units. So here, this is question relating to magnetism. Which of the following diagram represent magnetic field between two isolated unlike poles? Now, please take note. In a magnet, we have two poles, north pole and a south pole. And here is that they are unlike. That means that one will be north and the next one will be south. That means that when you have unlike poles together, and you know from law of magnetism, unlike poles attract. That means that there will be attraction of the magnetic line of force. Okay, now so definitely option A and B are out of it, because you can see that there is repulsion between the poles. So that means that it is out of it totally. Then what will now be the answer among the remaining options now? So look at option B here. You can see that the magnetic field originates at the south pole and terminates at the north pole, which contradicts what we have explained in our previous video, that magnetic line of force, it will originate at the north pole and terminate at the south pole. So how you determine from where they originate? It is from the direction of the magnetic field. So direction of the arrow indicates how it originates or terminates. You can see the direction now. So that means that it, from option B, it originates at north pole. You can see the direction. So that contradicts the theorem. So and then option E is also out of it. The direction is correct and also attraction, but they don't move in circular. Magnetic line of force doesn't move in circular, so it will not be in form of circle like this. Okay, now why the correct option is D. So it originates at the north pole and terminates at the south, and then the magnetic line of force attracts. Okay, so The next one we have here, so we have that you are asked to calculate the force between molecules of the same substance is called cohesive force. It is called cohesive force. So cohesive force. So inshallah, this is where we shall be stopping for today. So next time again, we shall be coming with more questions on related topic we have discussed. So until then, assalamu alaikum warahmatullahi wabarakatuh.